Science Consciousness Explained.
Picture someone cruising down the open highway, belting out their favorite song flawlessly. Every single lyric hits the beat. But 10 minutes later, that same person is standing at a cafe counter, struggling for several agonizing seconds just to say the word coffee. This highlights a specific quirk of the human brain. Activities like singing, whispering, or even mimicking a foreign accent can bypass a stutter entirely. Yet the simple act of introducing yourself to a stranger can cause the vocal system to entirely lock up. For decades, the medical consensus treated this as a psychological flaw. Experts traced the cause to a shy disposition, or to nerves triggered by strict parenting and high-pressure environments. Long-term prospective studies have since dismantled that idea. Researchers tracking young children found that those who develop a stutter show no more anxiety or timidity than their fluent peers before the condition first appears. Stuttering represents a deeply human collision, a synthesis of a physical predisposition and the intense weight of social interaction. To understand this collision, we have to look at how the brain generates speech. Our brains utilize two entirely different neural highways to turn thoughts into sound, a framework known as the dual premotor systems hypothesis. The lateral pathway serves as the external, rhythm-based route. It takes over when you synchronize your voice to an outside stimulus, like following the melody of a song, speaking to the beat of a metronome, or adopting an accent. The medial pathway serves as the internal, goal-directed highway. Your brain relies on this circuit, which runs deep through the basal ganglia, to formulate spontaneous thoughts and hold a normal conversation. In people who stutter, this medial circuit contains a biological vulnerability. Research indicates this is often linked to a dopamine imbalance within the basal ganglia, which disrupts the coordination required to initiate speech. Since everyday conversation relies on this medial highway, spontaneous speaking becomes a biological minefield. However, when that same person sings, the brain routes the traffic onto the lateral highway, leaving the vulnerable circuit behind. The basal ganglia functions as a hypersensitive, overreactive alarm system, remaining quiet until the specific pressures of the environment change. Social evaluation serves as the primary trigger for this alarm. This is the intense, often subconscious pressure of being judged, observed, or graded by a listener. Under this social pressure, the brain's internal self-monitoring system transitions from subconsciously tracking speech to consciously hyperfixating on potential errors. When a person tries to deliver a highly important message, saying their own name or addressing a waiting crowd, this hyperfixation ramps up, flooding the brain with warning signals about a potential mistake. Stuttering occurs when a biologically sensitive brain interprets the normal friction of social interaction as a catastrophic threat. We can trace the exact split second this freeze occurs. When the self-monitoring system detects a perceived social threat, it routes warning signals directly to a specific control center, the right inferior frontal gyrus. This control center overreacts to the influx of warnings, instantly engaging a hyper-direct inhibitory pathway to prevent the speaker from making an anticipated mistake. The physical result is total global motor inhibition. The muscles required for speech receive an abrupt halt order, locking the vocal cords into a silent block or a rapid repetition of a syllable. Trapped in this neurological lockdown, the speaker must either painfully push through the physical tension or rapidly swap their intended word for a synonym to bypass the triggered alarm. The stutter is an involuntary biological defense mechanism, a misguided attempt by the brain to protect the speaker from perceived social errors by shutting down the physical hardware. Historically, treatments focused on physically forcing fluency. Demanding perfect speech in this way only heightens the brain's threat response, which often makes the neurological blocks more severe. Modern speech therapy is shifting toward a model of acceptance. Rather than fighting the physical block, clinicians help individuals reduce the fear and shame associated with their speech. Lowering the fear of social judgment reduces the affective pressure in the brain's self-monitoring network. With fewer warning signals bombarding the control centers, the frequency of physical blocks often decreases. This change relies on the communicative environment. The patient's body language and reaction of the listener directly impact the speaker's internal neurological feedback loop. Since social judgment physically alters how a stutterer's brain functions, the solution extends to all of us. How can we change our own listening habits to give them the neurological space to simply be heard?